All right, in this video I'm going to talk about the velocity and acceleration of a moving object. So suppose our object moves with position function s equals f of t. If we take a look at the derivative of this function, f prime of t, we get the rate of change of f, or in other words, the rate of change of position, and we know that to be velocity. Okay, so if s is f prime of t, then ds dt, the derivative of s, is the velocity. If we then take the derivative of that, we get f double prime of t. F double prime of t is the rate of change of f prime. So that's the rate of change of velocity, and that is exactly the acceleration. Okay, so in other words, if s is position, then ds dt is the velocity, and d2s dt squared, the second derivative of s with respect to time, gives us the acceleration. Okay, so the hierarchy again is we have position, the first derivative of that is velocity, the derivative of that is acceleration. All right, let's do an example where we find these different functions. So suppose we have a ball thrown from the top of a 150-foot cliff. So if that's the cliff, we've got someone up here throwing a ball. It's going to go up into the air, and then it's going to drop. So we have an initial velocity upwards of 40 feet per second, and the cliff, like I said, is 150 feet off the ground. Then the position of the ball relative to time is, what's that measuring is the height above the ground. Okay, so here's the ground down here. This is 150 feet. So at each instant in time, the value on s is giving us the height of the ball relative to the ground at that point in time. Okay, so the position function of the ball is s of t equals negative 16t squared plus 40t plus 150, and that's if we neglect air resistance, which we will. We want to find the velocity and acceleration of the ball. Well, we know that the velocity of the ball is just the first derivative of the position function. So that's going to be the limit as h goes to 0 of s of t plus h minus s of t all divided by h. So this is equal to the limit as h goes to 0 of negative 16 times t plus h squared plus 40 times t plus h plus 150, and then we subtract the function. All divided by h. Okay, the way we're going to evaluate this is we'll multiply out this t plus h squared. Okay, if we also distribute the 40 in that step, this is what we end up with. So now let's distribute that negative 16. Okay, then we have a lot of things that are going to cancel. So this negative 16t squared goes away with that 16t squared. Let's see, the 40t goes away with that 40t. The 150 goes away. Then we have negative 32th minus 16h squared plus 40h. The last thing that we want to do is factor out an h. Well, not the last thing to do, but next we want to factor out an h. And we can cancel. So that leaves us with negative 32t minus 16h plus 40. So now we send h to 0. This term is going to go away, and we get negative 32t plus 40. Okay, so this is the velocity of the ball. Okay, so you'll remember that I wanted to find the velocity and the acceleration of the ball. So now that we have the velocity function, we differentiate it to get the acceleration function. So a of t is the derivative of the velocity function. So it's the limit as h goes to 0 of now v of t plus h minus v of t all divided by h. And this is going to be a lot faster to find. Just kind of as a heads up, we are differentiating a linear function right now. So we know that the derivative gives a slope. So we know that the value of the derivative is going to be this negative 32, because that's a slope. Okay, so we know the answer. Let's just go through the process to find it. So we have v of t plus h, so negative 32 times t plus h, plus 40, minus v of t, negative 32t, plus 40. And that's all divided by h. So we can go ahead and multiply things in and cancel. Okay, so let's get rid of the 32t and the 40. So then we have the limit as h goes to 0 of negative 32h divided by h. Okay, the h's cancel, and wow, what a shocker. The acceleration is negative 32. Okay, so I want to put units on these. Let's see, distance is measured in feet, time is measured in seconds. So I know that my velocity function, if I were to plug in a particular value of t to find the velocity, I know it would be measured in feet per second. And now acceleration is velocity over time, so that would be feet per second, which is feet per second squared. So of course we find that a of t is negative 32 feet per second squared. And another reason we're not surprised is because it's the acceleration due to gravity. And we know that that's going to be what happens when we have an object in free fall. Okay, so that's how you find velocity and acceleration if you know the position function.